Tell me about it. I have class after school. All right, let's start with number 6. Use the data in the table for exercise 6 through 10. Well, let's plot it first. The first one is 10 and 2.7, so around here. I hear whispering over there. And then 20 and negative 2.3, so around here. And then 30 and negative 5.5, around here. And then 40 and negative 7.8, so close to 8 almost. And then 50 and 9.8, which is close to 10. And then 60 and 11.4, around there. So can we see a trend here? Totally, right? What kind of trend is it? What kind of association? It is a negative association. That's what the trend line shows. So you can, where do we start the line? At the top point? We are talking about wind speed and wind chill. One causes the other, right? So tell me, where do we start the line when we draw it? Yes. Where? There is no y-intercept. I don't see any points in the y. Where? On the origin. What would be a justification for that? Well, I know it's 0, but why would you start at 0? Context. The what? Well, keep going. What? No wind chill. That's it. That's all. If there is no wind, there's no wind chill. Wind chill. So you will start at 0 because when you have 0 wind, you have 0 wind chill, right? Obviously, you do not feel a wind chill if there's no wind. So it makes sense to start over there, even though the one on top was kind of crazy. It was hotter. But you could say that you could start at a point right here and go this way. Right? That was kind of like an outlier, the one on top. Like, it makes no sense. Like, what happened? Why was it cooler and then it's like drop? Yeah. So write the equation for your trend line. So if we're going to use 0, 0 as a trend line, what other point can you use? So notice the line that almost basically goes through this line right here. So I will use 70 and 12, negative 12. That's my second point. So yesterday we talked about that if you don't have any points that are on the line, make a point on the line so you can use your slope. That way the slope will be related to the line and not some random points. So if you use those, you should end up with m equals y2 minus y1 over x2 minus x1, which is y would be negative 12 minus 0 over 70 minus 0, which gives me negative 12 over 70. You can simplify that to 6 over 35. So when you calculate this, you get about 7 points. Well, it's negative. When you calculate this, you get 0.17, I think. Yes. Well, the trend line has to go between all the points, right? That means you have to have points above and below. When you create this trend line, look at it. You have points above and beyond and below and right on them. So if you don't have, you could have used this point, but that would be hard to calculate. However, it's easy to calculate or to find the points that are literally at the intersection of This line, for example, and this line. Look where the point meets. Right on those lines. This point right here meets right there. That's not very easy to estimate the number for the x, right? Right here won't either. Right here won't either. Right there won't either. This one might work, but it might still be inaccurate. So it's better to use one that is right on the line. See, like that one doesn't cross this. It will be outside. So yeah, you have to find a point on the line that you drew. And if there are no points on the line, then create one that is at an intersection of the y and x lines. I use 12 and 70 and 12 because that one point lands literally on the two lines, right in the middle. So the formula says y2 minus y1 over x2 minus x1, and then you put it together, you get negative 12 over 70. You simplify it to negative 6 over 35, and you can divide 6 by 35, you get 0.17, negative 0.17. So your equation should be y equals negative 0.17x. That's it. You don't have any b. Your b is 0, essentially. So if you had anything, actually, you guys right here, quickly, actually, no. You grab 5 calculators for the people right here. You grab 5 calculators for them. You, and then you. Make it fast, not you. Just, you have enough. Make it fast. All right, now that you have your calculators and you're not walking around like a zombie, you're going to divide whatever, if you get a fraction for your x, for the paper that you're grading, divide the top number by the bottom number, and that should give you a decimal close to what I got, negative 17. So I take anything from negative, I would say 10 to negative 20. I'm making that a big range. So everyone, whatever you have in your paper as the slope, divide it like I did, 6 divided by 35, and it should give you a decimal. If you already have a decimal, then it has to be between negative 0.10 and negative 0.20. Do we have any questions on this? Are you grading your own papers? Good. Yes, but some people forget. Hurry up. What did you divide? Guys, you are not, let me say this one more time. You are not dividing what I just did. I already got the answer for that. I don't need you to divide that. I'm telling you to look at your paper and look at what you got for the slope on your paper. This thing right here. If you get a decimal, it has to be very close to that. If you get a fraction, then divide the fraction by it. And that should give you a decimal. If it's not close to it, it's wrong. Do we have any questions? Yes, it has to be negative because it has a negative slope. If it's positive, you did it incorrectly. Do we have any questions? Can I proceed? Good. All right. Use a trend line to predict the wind chill at these wind speeds. 36. How do you figure out 36 then? How do you figure out? Plug it in, right? You plug it in, y equals negative 0.17 times 36, and that should give me the wind chill for that, right? So whatever you had that you found, let me say this one more time. Whatever you found when you calculated this on the paper that you're grading, type in 36, and that should give you the answer that should be on there. It should be a negative answer. I'll do for mine. So 0.17 times 36, I get negative 6.12. So that means for you guys, you should be right around that amount, that number. If you got 7, I'll get it. If it's 9, that's too much. I'll get between 5 and 7. Nothing more or less. And would you say that that information is interpolated or extrapolated? It's interpolated, yes, because you can find that value falls within the range that we have, right? 36 is around right here. Extrapolated is when you cannot find it in the data. It's outside, you're predicting. For this one, it already happened. So how would it be for 100 miles? Point 17 times 100, that gives me negative 70, wait, negative 17. I'm sorry? I will take between negative 15 and negative 20. There shouldn't be any points there. So what is the meaning of the slope here? The meaning, what does it mean, the slope? Hey, I'm over here. Let's not read it. Let's tell me what the meaning of the slope is. The slope was negative 0.17. What does that mean? What does the line mean? What's going on there? Yes, but how is it changing? Can you explain to somebody? Yes, the higher the wind, the lower the temperature. That's it. That's simple. It's a negative slope. So basically, the harder the winds, the higher the winds, the lower that it pushes the temperature. All right. The next one, let's plot it really quickly. 0 and 64 here. And then 20 and 67. And then 40 and 70. I hate these. Because you cannot find the point. You have to estimate. And then 60 and 72. 72. And then notice that one lands right on it. You're going to use that point, most likely. And then you have 80 and 74 around here. And then 176. Oh, that was right here, sorry. And then 176 up here. So let me... So when you draw a line, you have a point right here, right? And then you can use this one right here because the other ones are either above or below. So I can use 0 and 74, right? No. 64. And then I can use this one, which is 60 and 72. One day. One day. Huh? All right. Make a scatter plot. We did. Draw a trend line. We did. Write the equation. No, we didn't. We have the values. This is 1 and this is 2. So you do 72 minus 64 over 60 minus 0. So you get 8. 8 over 60. You can simplify it to 4 over 30 or 2 over 15. So you can say y equals 2 over 15 x. Do we have a plus b? Absolutely. We have a y-intercept, right? And it's at 64. That's your intercept. 64, right? And you can actually divide 2 by 15, and you should get a decimal that you might actually use better. No, it's not 7.5. It's 2 divided by 15. So you get y equals 0.13 recurring x plus 64. So either one of those I will take. I will not take anything different. Unless it's very, very close to 0.13 when you turn it into a decimal. Who's confused? What did you get? How do you get 48 minus 0? The first one is not 48. Um, it's not the best one, but here's the thing. Yes, the first number that you need to use is this one because you know it for sure. It gives you an accurate start. The other one is whatever number you find in the middle. And this one happens to be right on the line. That was intentional. So you can select that point particularly. Divide whatever number you got, and if it's close to 0.13, I'll take it. What did you get for the slope? What did you get? I know. What did you get? What fraction did you get? 48 over 2? 48 over 12? That is automatically wrong. Even if you simplify it, you have an improper fraction, which gives you a higher number. It gives you a number that is higher than 1 already. And our number is very close to a 0.10. You didn't flip it, or you used the wrong numbers. If you use 48 and 72, is that what you said? That's over here, and 72 is up here. You will need another number over here to find the other one. What was the other number? Give me the coordinates. I need coordinates. What went wrong? What do you subtract? The what? For here? Did you have this? So you flip those? That means you're not very. Am I still recording? Yes. That means you didn't do this right. Follow this. Follow that. Otherwise, your calculation will be wrong all the time. This is my second point, so that's my x2 and that's my y2. This is my first coordinate, so this is my x1 and my y1. So all you have to do is grab those values and plug them in, literally, and it gives you the answer. That should be a very simple thing to do. If you cannot do that or you're not very good at that, then use rise over run. That's going to give you 8 when you rise. And if you run, it gives you 60. That's it. Yes, because you got the wrong calculations. Do we have any problems with this part? Who does? What is it? Yes. What is that, by the way? What is that we calculated? The slope. In the equation, what letter is the slope? What does b mean in the slope, in the equation? The y-intercept. Do we have a y-intercept? Where? 64, right? So are you still confused? All right, use a trend line to predict the apparent temperature at 70% humidity. What would you do? You can estimate it by looking at it or by plugging it in. So by looking at it, I can go to 70 and say it should be around 73, right? It's right above 72. But why don't you go ahead and actually plug it in into the calculators? 0.13, oh, 5 over 15 times 70 plus 64. Let's go. So yeah, my prediction was pretty close. So you can do it just by looking at it or by calculating it. So y equals what? That's it. What is the meaning of the y-intercept of the line? What does it mean? What does the y-intercept mean? Basically, the temperature when there is no humidity, right? When you have 0% humidity, the temperature is 64. That's it. I didn't give you this, did I? I did. It's impossible to draw a trend line on a scatter plot that shows no association. Why not? There is no direction, right? So it's not possible. Sam drew a trend line that had about the same number of data points above as below, but did not pass through any data points. So, hang on. He then picked 2 data points to write the equation for the line. Is this correct? What is a better way of explaining why that is not correct? At the intersections? You have to get the points from the intersection of the line. So if the points don't, like, if you randomly selected 2 points, you could have selected these 2. Is that the same direction as the line? No. Or these 2. Not. And then these 2, well, that one, that wouldn't work either, right? That's why it's important to stay on the line. Do not select the points randomly. Select whatever is really close to the line or any intersection at the line. So yeah, he was wrong for that. This one was basically talking about why would you, if you agree with her method or not. Well, she seems like she only collected 2 information. Can you make a prediction based on 2 points? You need more points. You cannot have just 2 because that could go in either direction. What about the other one? What do you get for that? What does this data show about Merlin's conjecture that the population of Texas counties is approximately equal to the area? The explanation for the book was a little weird. It just said that you selected 2 that were very close to each other. I don't know what that means, but it was weird. All right, move on to the next part. You can swap. Who did not complete their homework? Push your hand. 1. Okay. Who didn't do their homework? We're gonna jump into sampling. Sampling is a little different, and we're gonna talk about. In a minute. All right, for those of you who are ready to learn, we're gonna talk about mean. Can somebody tell me a quick definition of mean? Emily. Values. Uh-huh. Yes, exactly. Yes. The average. The what? That's to find the median and the range. But the mean is based, yes. Yes. So you basically, when you're looking for the mean, you're looking for the average, like your grade. Your 6th grade is an average. We add up all your grades, and then we divide them by the amount of grades that you have. So if you have 10 grades, we're going to add all those grades and then divide it by 10. That's simple. Yes. Yes, exactly. That is the mean. You should have learned that last year, but it's a quick refresher. Okay. What is variability? What comes to mind when you say something it varies? Yeah, it's different, right? It could range. It could be different from at a particular point. Uh, the the best thing that I can relate this to is your grade on the STAR Freeze Day exam. Let's say that the average was a 70, and some of you scored above the average, and some of you scored below the average. The mean absolute deviation is basically a measure of the points that you were off from the mean, from the average. So let's say that the average is 70, and I don't know, Jennifer was not on her best game that day, and she got a 60. She is 10 points below the average, 10 points below the mean. And let's say that Edgar just really studied that time, and he got a 90. That means he was 20 points above the mean, right? That's all this means. Yes. Yes. All you have to do is basically calculate the distance from the mean. So in this situation, I want you to get all these points, add them up, divide them by the amount of points, and find the mean for it. Totes McGoats. All right, so you add them up and you get a particular number. You divide it by the amount of numbers, and you get 59.1, right? So 59.1 is approximately 59 when you round it, right? That means you did something wrong. Trust me, I did this in my first period. I know what I'm talking about. So I'm not going to do it again because it'll take time. Okay, so all you have to do for the bottom, yes, all you have to do is to find the difference between the number up here and the mean. What is the difference? 1, that's it. And right here is 1 again. 5. Why are you mad? Because they know it? I'm just kidding. I'm kidding. I'm kidding. So, whenever they talk about distance from the mean, they literally mean how many points away from the mean is this number. That's it. I don't care if it's it's not going to be negative or positive ever. At least in this situation, they just want to know how far is it from the mean. That's it. All right. Now the next part is to calculate the mean of these guys at the bottom. Add them all up. Divide them by 10. Is it 10? 9. Divided by 1, 2, 3, 4, 5. Yeah, by 10. And then that should give you the mean of the distance from the mean. So basically the mean absolute deviation is the average of what you just calculated. The MAD is this when you calculate it. Add all these up. What do you get from when you add them all up? So when you add all these up, you get 27. And then you divide it by 10, you get 2.7. It says round to the nearest whole number. Yep. Approximately 3. And that's it. Now, find the mean of that, of the one at the bottom. Ahead. So when you add them up, what do you get? When you add them up. 449 divided by 9, there's 9 of them, right? So when you round it, you get 50, right? Boy, it doesn't matter. I am recording, am I? Yes. There you go. You basically round it to the nearest whole number, and it'll be 50. Yes. This is the easy part. All right. So these numbers up there are the same numbers as the one on the bottom over here on the next page. So what I want you to do is to find the distance from the mean for each of those numbers, and then give me the MAD, the mean absolute value. Again, to find the mean absolute value, you have to add all whatever you get here and divide it by the amount of numbers. I'm going to say it one more time. Hey, everyone listen. You already calculated the mean for this table. Now all you have to do is find the distance from the mean, put them in the table. Once you get that, then you can find the mean absolute deviation, which is you find the average of the numbers at the bottom. That's it. No, ask. Okay, so let me go back over here. Do not lose me. So we have these numbers, right? The height. Are we following? And we have to find the average for that, just like your test. So the average for that was 59. Are we good? Now we have to find the distance from the mean. And that's what we do when we look at the ones that are close. I mean, how far is it from it, right? Are we good? Edgar, I'm over here. You're not going to get it from the video if you don't get it now. So it's right here. And now when they ask you to find the mean absolute deviation, all you need to do is find the mean of the distance. That's it. Okay. Is anybody else confused? What part? How do you get what? I'll put it in steps. Hang on. Step 1. Find the mean of your numbers, whatever number are given. Step 2, find the distance from the mean. So in other words, if your mean was 59, find the distance that all these numbers are from it. So 60 is 1 from 59, right? 58 is 1 from 59. 54 is 5 points from 59, and so on and so forth. Do you understand that part? Are you following? So the third step is to find the MAD, which is the mean absolute deviation. To do that, you must find the mean of the numbers that you got here. So you find the mean of all of these numbers. We added them, and we got 27. You divide it by 10, and this is your MAD. Are you sure? Okay. Let's go. Let's keep going. Sure. All right, we're back. What is the distance for this one?
2, 4, 2, 7, 2, 5.
So, no, it's just the number, the points away from the mean. That's it. It's not negative or positive. Just the points away from the mean. And how do you find the mean? What do you get when you add them all up? And then you divide them by what? So you get approximately 4, right? The mean. That's fine, because I know. The point is that you're rounding to the nearest whole number, so it doesn't matter. Because that 8 will still turn it into a 4, right? That's it. So focus on this. Now look at this MAD is 4. The other MAD, it was 3. Do you think it makes a difference about the distribution? How so? Thanks. Distribution? How the values are spread out, basically. Let me give you an example. If the average was a 70 and most students get around a 70, do you think their distance will be big or small? Small, right? Because most people get around a 70, so they'll probably be like a point or two away. That means the mean will be very close to 1, the MAD. But if you have numbers, if the average was a 70 and you have like 80s and 40s and 50s and other numbers like that are spread out, then the distance from the mean will be very big, right? Which means the average will be a lot larger. So what I'm trying to say with this is that the bigger this number, the bigger the MAD, the more spread out the values are. That's what it means. So when you have a very small MAD, that means most of the values were around the same area. So in this class, technically, you're supposed to have around the same grades. Technically. All right. What does it stand for? Everyone say it. Mean absolute deviation. So here's another example, Edgar, and those of you who are still a little confused, you may take these pages with you so you can look at them and use them as guides. The what?
The homework.
Your homework would be,
The next page. 418.
where'd it go? This one. No, this one and the guided practice. So the whole page, no, it's one page. It's just one page. Okay, good. Ah, what are you guys eating? Y'all being loud today. You don't raise your hand and start talking. That's not how you do it. Okay, so you go to page 417 and you're going to do the guided practice from 417. Actually, the whole page when you get to this one. The whole page on 417 and the whole page on, well, not the essential question. We can do this in class. And the 418, which is one page only. Front and back, right? There we go. It should be easy homework today.